Okay. So anyway, there are some notes here. If you all don't have this, you can get a copy from me later lah. Some of you have already, I think. Yeah, so you don't need it. Then Redox one, I think I should have gave out also. Okay, so later we might use some of these to recall some of the concepts. Okay, so today we do the mole concept and redox calculations. Maybe it's just to prepare for. I mean, it was not intentional lah. Okay, but it will help you for some of your practicals because practicals, most of y'all would encounter titration, redox for one of the segments. Okay, but what you probably need to study is your QA also. So I know most of you are bad at practical, which is the common complaint. But my advice is this: for prelims purposes, right? If you are thinking of prep, actually it's 20 versus 80. So if you are looking at your 80%, your 80% is your paper 1, paper 2, and paper 3. Okay, of which your paper 2 and 3 is the highest weightage. Then this is your practical lah. So in the norm situation, just to share, because now you are no longer in the SPA era where everyone does the same prep, you wouldn't know what's coming out, right? So usually, because practical is out of 55, the 20% is out of 55. So based on what I understand, usually if you are able to do the experiment but not able to answer all the questions and calculations, most students can pass one. Most students can pass. Not your A levels, of course. Okay, most students can pass. So you are looking at around 28, right? Out of 55, plus minus. This is around 50% plus minus. Okay, but the division is really not that bad because if you are looking at 50%, sorry, 50% means this is 10%. It's 10% of the practical. Let's say you are the kind that's quite ambitious, right? And then I think that day I was telling Darren, so I thought I would just share this with you because Darren was also voicing our concern, and he's not alone. So if you are looking at aiming to get a 15%, which is a good A grade for practical, you probably have to score quite high, which is around 41 out of 55. You get what I'm trying to say? I'm not saying that you can't do it. I'm saying that now your priority shouldn't be on this yet because there is a big jump. You get this 5%, that means I'm talking about you passing the prep, which most of you are probably able to scrape a pass. If you can do the experiment and manage your time well, maybe you can't answer all the questions, that's okay. And maybe you fake a bit of data here and there, okay? But to get a 15 is really quite challenging for now because your school preps are most likely very tough and time consuming. A levels a bit different. A levels will try to make it more manageable. All along it has been okay. Okay, so you do not have to worry so much. It's mainly whether you can answer the questions at the end of the day. Now most of you are saying that you cannot complete the school prelim or school practices, which is a norm. No? Okay, usually you expect about 3 experiments in one prep. Okay, so it's quite tough. Okay, you know why I say so much? It's because I really need you to tell yourself, don't get too hyped up over that because you should still focus on doing well for paper 2 and 3. If you can do so, then at least you can pass your prelims well. We are not asking A, B, I'm saying pass it well. Okay, so you are confident enough to take the A levels then all you know that practical you can later go and boost it up. Okay, and I will probably talk more about it after prelims also for planning. Okay, so let's talk about the mole concept. Today is very much practice based. So less talking from me, more practice from you. Okay, so if you don't have paper, please do it on paper. Okay, if you can get from me also. Okay, so we have around 10 questions. We try our best to complete as many as we can. Most likely we'll complete until question 7. Okay, let's look at the first one. Okay, so the first one here is your back titration. So anyway, all the concepts are unique. I'll just quickly browse through it. Back titration, percentage U and group 2, percentage composition and gaseous state. Okay, redox half equation. You will have a hard time for this question. Okay, then exceptional oxidation states. Unknown oxidation states. This one is easy. This is a hard question, question 7. Okay, so we'll try that today, struggle through that. And the last 3 are the standard ones that you might expect in your practical. So redox back titration, dilution versus extraction. Question 8, 9, and 10. Okay, so let's try our best to practice that. Okay, because mainly your calculations, you have to do it on the spot. Okay, come, let's look at question 1. Okay, question 1 is a warm-up question. I will just give you a brief one, then you can try already. Those of you who are starting, just go ahead. Don't wait for me. Okay, so you have 0.2 of the nitrite. This is 0.2 grams. And then after you react, you produce ammonia. So ammonia is produced here. So what we do with the ammonia is that the ammonia is reacted with HCl. So this is reaction 1. Reaction 2 is that ammonia is reacted with the HCl. This is the HCl here, right? So after I react, I will get NH4Cl. The equations are optional. You don't have to write it. I'm just showing you. But what's important here is to recognize that this reaction has unreacted HCl, and you will require a certain amount of NaOH. So this is your back titration because you expect your excess HCl from here to be collected, and then you will use this for the back titration. So this excess HCl will react NaOH to form something you know very well. Okay. So can you try it very fast one? Please tell yourself that this is the total HCl, and total is reacted plus excess. Okay, simple one, just to warm up your brain. Okay. Yeah, but it's all right. Now, just go around and have a check some of the workings. This one. You took already, right? Yeah. Okay. You took already. Okay, this question no kick one. Okay, after that, then you will have more kicks. Okay. Those of you who are online, right? The PDF and the answers are all at the back of the PDF, so you can just check it on your own. But of course, if you encounter some difficulties, just send me to tell you check. Then at least I can spot your mistake. Okay, quite okay. Especially for the harder questions at the back. So, wow, excess, this excess, right? Excess. Yeah. So this one reacts with the NH3. No, it doesn't react. It doesn't. This one is the excess. Is it? Look at my screen. Excess. So you are trying to find for me the reacted. How do you find reacted? You think total minus excess. Yes. Huh? Nitrogen is 14. Yeah, 14. Yes. I will send you. Total is 70. Yeah. This is total. Good. Okay. So you must always remember that. If you are done and you can get the correct percentage, just move on to try question 2. Question 2 is the one that you would pluck your hair a little bit, okay, stress over it a while. Huh? Sorry? 40 normally you will get 41. Oh, yeah. Oh, correct. I think this is fine. 39, yeah. I'm referring to another question, sorry. So yes, you will get 39.9. Right, 39.9. Okay. Yep. So this one you will get. Okay. The next question, Alicia, okay? Yeah. Okay, the next question I want you to read through first. If you are looking at question 2, the equation that I probably need you to know or remember or mark, because most of you have learned it in your school notes under group 2, is this thing called thermal decomposition of group 2 nitrates. Okay, this is taught in planning also. It's under this concept of gravimetric analysis. Gravimetric analysis means that you heat a sample. The objective of heating a sample is to find out how much of a certain compound is in the sample. Okay, that's the idea. Okay, so we will not really do gravimetric analysis for the actual prep. Okay, because usually we will not like to do so much of heating in your labs. Okay, but anyway, going back to here, you probably need to use this equation, okay, which I can provide you, because if you not, you cannot start. But you really need to mark this equation. Okay. So calcium carbonate will give you CaO and carbon dioxide, right? That's something that you are probably more familiar with. So what I want you to do is this. You know the mass, right? Okay. Try to calculate for me, lor. What do you think will be the mass of the calcium oxide that's produced? But all of you will discover something that is quite peculiar here. Okay. Daryl, okay, no? The first one? Yeah. Okay, I'll check with you, I'm not sure. Okay. So Daryl, you use this equation for the thermal decomposition. So the question told you the mass of the residue. The residue by right is 2.92. But that's where things get confusing. Okay. So I probably will ask some of you, what's the conclusion? April. Those of you who are online, anything not sure, please just voice out. It's okay. Last time in school, nobody celebrate my birthday. You know why? It's because my birthday is always at year end. So that time is exam, November. So nobody celebrates your birthday in November. Yeah. Everybody is all concerned exam. Yeah, you use this to, okay. So by right, this is your moles, right, of the yeah. So maybe you try to punch it in. I just want to see a certain calculation for the mass of the calcium oxide that you are supposed to get. If I see that, then you probably need to tell me what's next. Yeah. Yeah, no mark. You can use mine. I wrote down already. Because this one you just need to mark.
So this like for in general
The nitrates,
nitrate.
but carbonate is just CO2. Also in my group 2 notes, so you don't have to worry.
Okay.
Oh, but right now, it's just to remind you that you have to mark it with this. Okay, so you use the moles of calcium nitrate to find out for me the expected mass of calcium oxide. For planning, I think you also must know how to do the calculations, the theoretical calculations, so you can show the working in your steps. Okay, you should be able to get 1.36 if I'm not mistaken. Right, okay, 367 or 37. Okay, so by right, the calcium oxide is 1.36. But how come the residue is so much then? Anyone? Just tell me if you can think of any, the people here. By right, by calcium carbonate, right? I mean calcium oxide, right? That I achieve in theory, we call this a theoretical mass, should be the 1.36 or 1.37. But based on the question, we say it's 2.92. Why? That's the hard part about this question. Alicia? Oh. Today you look more intelligent. No, just joking. But why? Try. Why the residue is more than the maximum mass of 1.36? You read this sentence, the third sentence, it will give you some clue. The third sentence. Any ideas why the residue is heavier than the...
It's like not pure.
No. If it's not pure, usually we will tell you lah. Or usually it will be quite upfront to tell you that this sample is not pure. Okay, we will not hide it from you that much. It is pure. Let's take it as pure. It is pure. Any other ideas? Daryl, you try. Why is it that the residue is simple reason? Really. Think simple. This is thermal decomposition, right? So what are we asking in the third sentence? You see?
Is it like not complete?
Yeah, not complete. Yes. Okay. So can you all write down, based on this theoretical mass of 1.36, right? We realize that the residue is more than 1.36. What does it tell me? Okay, I will elaborate on what Alicia mentioned. She's saying that the thermal decomposition, I'll write down here, the thermal decomposition is incomplete. Why? Or how do we know that? It's because the final mass of 2.92 is higher than 1.36. So I would make the conclusion by telling myself that this residue is CaO in addition to, you can write this down, in addition to the undecomposed calcium nitrate. It looks simple, right, this question, but it's really not that simple. Okay. So you will have the undecomposed calcium nitrate. So it's still lurking around, which is why the question actually did hint to you. If you bother to read and think a little bit more, right, then the third sentence is in fact hinting to you that the heating didn't result in 100% breakdown, because we still ask you for percentage U. If you get 1.36, right, The percentage yield is 100%. The percentage yield is 100%. But if you get more than 1.36, that means there's still undecomposed calcium nitrate present. Okay? So how then do you solve? I let you all think a little bit first. How then do you solve? How do you find out, right? What is the actual amount that managed to decompose? There aren't that many numbers, right? There are only two numbers to play with. The 15 minutes is useless one. What can you use to, in this equation, maybe I'll give you a hint. What can you use in this equation to solve for the moles of calcium nitrate or the moles of calcium oxide that was really produced? That was really produced from the decomposition. Think about it. Okay, just slowly, just slowly. Any ideas?
Is a bit of zero and no, that's not finished from that's how you value them or something. So it's like 1 point something of the extra 14.
The extra is the calcium nitrate, right? So 1.36 by right is the maximum. Okay, but actually this part didn't have 1.36 by the way. The 2.92 didn't have the 1.36 because this is the theoretical one. You cannot claim to me that 1.36 of calcium oxide is hidden within the 2.92. Okay, because this is in theory. In actual fact, we don't have that. So if you all still remember a formula that you all have learned in percentage yield in mole concept, percentage yield is always equals to the actual mass over the theoretical or the expected mass times 100%. I mean, this formula, you all know it. But it still comes back to the question, how do you solve for the actual mass? Actually, you have done this really. You have solved for me this one. In fact, all of you have gotten the 1.36 or 1.37, right? So I have gotten this really. But I probably need you to tell me, how do I find out the actual mass of calcium oxide that's produced? Should I focus on the calcium oxide or should I focus on other things? The gases. So since Darren mentioned, what do you think are the mass of the gases? Yes. Okay, so let me just do a bit of highlighting here. You will then realize, that this difference here of 1.08 grams is actually the gases that were produced because you lost this mass. This mass was lost. These gases were also lost. Let me erase this equation so it's not so confusing. So if I were to look at the state symbols, this is solid, solid, gas, gas, right? So I will then notice that the gases are lost. If you know the moles of gases that are lost, you can work backwards to find the actual moles of calcium oxide produced. But you need to perform a bit of algebra or some simple ratio concept. Think about it. How do you equate the 1.08 to this box? Okay, that's what I'm trying to get you to do. How do you equate this? This one we can test for planning, by the way. Okay. How do you equate these two? Can you think of an expression, a one-liner, to match these two yellow chunks together? I'll give you a hint. You will probably tell yourself that the ratio is 1:2 is to 0.5, right? 1:2 is to 0.5. So you can express this in units. So let's say this x, this will be 2x, this will be half x. Okay, you want to try that? Next time you must write it out already. This time I'll help you. So if you know the moles, you can solve for the x. It's just a one working to solve for one unknown. Okay, before I show you the working. Okay, I'll write down a little bit here so that you can see it. Okay, so you can take a look at this one. So by right, I actually want you to think of this. Okay, so at least the harder calculations you are able to try to figure out on the spot. Okay, so this is something that we would talk about in gravimetric analysis. You try. After that, it's okay with it. All of you can solve with it. Then calculate for me the x. Okay. You'll get your 41%.
So what do we define as x?
Huh?
And what do we define as x?
X is the most of CaO.
Oh, okay.
Right? If this is x most and this is 2x, this is half x. So actually, not so crucial to write the let x be what in the exam. So yeah, as long as finally you get the correct answer, usually we'll just mark it. Okay, so it's not really like maths where you have to write every single thing. But good that you know is x is the most of calcium oxide. Okay. The x also big. Let me check. Oh, okay, 0.06. Then after you get your x, you can calculate the actual mass of the CaO. Okay, that's what you're supposed to do. Yes, this is okay. Then, not much of issue. Okay. So I will just flash out here. You double check your x. For Josh, your x is this one. Yeah, it's just calculation error. Double check. Okay, the last part of the question they ask you, right? How do you ensure that the percentage U is high? So in this case, most students will say like hit longer. Right? I ask every student, right, they'll tell me hit longer. Then my reply to you is hit how long? Hit until infinity, man. Okay, so you must be a bit more specific. Okay, hit until you obtain 2 consistent readings. Then you will stop already. Okay, of course it's over time now. So this is like your precautionary steps. Okay. Okay. Anyway, my working is slightly different, but all of you will get the same value for x equals to 0.01. Okay. Alicia, okay? Yeah. Okay. Okay, definition in question 3, I'm not so bothered. You can move on to start from 3b. Then you can start from there. Question 3 is easy. I must tell you that it's easy. So can you try first, then I help you? First, let me see yours. Right. You double check whether you got any calculation. Okay. Then, well, past 2 days keep raining, right? Right. So, wow, damn sian. Our side. Wednesday, no, Thursday. Yeah, Thursday was super heavy rain on the morning. Oh. Okay, so question 3, you probably should start trying from part B. The definition you can just copy from my version. Okay, it doesn't really matter, right? George, you got down, sorry, this one, hit the until too consistent. This is the one that they say, what must you do to ensure high percentage use? So don't say hit longer, okay? Because you hit longer, it's not.
I say hit longer until too consistent. Actually.
Of course, yeah, of course, yeah. So don't just hit longer, full stop. Okay. Okay. B part 1 and part 2 are easy. They are part of your atomic structure concepts. You probably need to remember that what we are looking at is this concept of isotopes. Okay, so if you're not sure what these are, these two are isotopes. Okay, so I'll just revise this very quickly. Isotopes, right, means that they have different number of neutrons. Okay, so if you have different number of neutrons, right, isotopes always have different masses. If they got different masses, they got different physical properties. Okay, but this I'm just digressing lah. Okay, this is just to remind you, right? But isotopes will always have the same chemical properties because they have the same number of electrons and protons. Okay, mainly the electrons. Okay, so they're asking you why the AR of diamond, right, is not 12. Okay, so by right, we expect diamond to be just 12.000, but why is it not 12? Then your answer lies in the top part, right? You should consider the presence of both isotopes, right? If they are both isotopes present, then you usually will not get a whole number value because you realize that 12 to 13, this is 12, this is 13, and your so-called average mass is 12.011. So that means you have a mixture of carbon 12 and carbon 13. Huh? Of course. No, you are supposed to know from the question because by right we don't know that. You are supposed to infer from the question because we notice that these two are present. So if you are looking at the MR, this is, or the AR, this is 12.000, 12.003. Then I noticed that the value is 12.011. So it's in the middle, or rather closer towards the 12. So the best answer you can give me is that you tell me that actually carbon or diamond has a small percentage of carbon 13. The not so good answer, which is also acceptable, you just tell me that carbon contains a mixture of carbon 12 and carbon 13 electrodes. Sorry, not electrodes, isotopes. Okay, contains a mixture of carbon 12 and carbon 13 isotopes. But actually, we can infer because the value is closer towards 12. That means you got more carbon 12. Okay, this is just something to add on. Okay, so I would prefer you to write this out, which is better. Or higher percentage of carbon 12. Also okay. Okay, the next one I'm going to help you. That one is your Sec 3, Sec 4 or J1 formula. Can you try that? It's just one equation, one unknown. Okay. Then after you think about part C. Question 3 is manageable one. Josh, are you cold?
No, I'm fine.
You're cold because you take over Darren's jacket. Or you can wear the one on top. Why would you be cold?
Yesterday
I was going to say something lame, but I decided not to.
Yeah. Since you think already,
Must say, right?
Yes.
Because Darren is too hot.
Oh.
So he take away all the heat. So you take away all your heat. Later, after every lesson, I keep praising Darren, then one day you become very egoistic. That's why I change the phrasing. Maybe it has changed. Yeah.
You know the truth. When you don't need to say, that's right.
Yeah, that's right. Unspoken truth. Okay. Part 2, please remember to use the average formula. I will use this to go through another concept. So if you are looking at here, part 2, what you are trying to do is to find a percentage of carbon 12, right? So you'll put the unknown as carbon 12. So I'll put an X here. Right, X will be for carbon 12. Okay, so this is for 12.000. Then you have 100 minus X, which is the carbon 13. Usually I'll put the unknown as the one you want to find, or the question is one you want to find. Then divide by 100 equals to 12.011. Okay, I want to remind you this formula, right? Not just for this simple concept. There is one more scenario that you will use this formula. Okay, so after you jot this down, maybe I will remind you again. Okay, can you just calculate the X first? Then I will talk about organic chem. Okay, I just digress. Okay, those of you who are faster, you can do C first. You don't have to wait for me. Then I will just stop you in between to tell you about this formula again. Then you solve for X. You know why I like to use this? Because I'm finding percentage. So I use 100 minus X and X. Some of you like to use 1 minus X and X. But if you are doing that, then your X will be 0 point something. Then you must remember to convert. Actually, it's the same thing. But some of you will get a bit confused. Okay, so either way is fine. Okay, everybody can get 98.9? Josh, okay, this one. Okay. Okay, I just interrupt you all a while. I want to use this to bring up a concept that you have learned for organic chem. Remember this concept about optical isomerism? So you have these isomers. So you can take a short break. So you have two of them here. So most of you know if you have two optical isomers in 50-50, they will not rotate plane polarized light. Okay, so this is what we call as a racemic mixture. Racemic mixture, it has to be 50-50. And we know that racemic mixture is optically inactive. It does not rotate plane polarized light. But this is the easy version. You probably should be aware about the formula if I ask you to calculate what happens if both of them are not 50-50. I could be looking at a scenario of 40 and 60%. Okay, so I want you to remind yourself of this one. So for example, I have this one that is positive 15, clockwise rotation. Of course, we will tell you this if that's the question, okay, negative 15. So this formula is the same as what I introduced to you just now. What you need to do is to take 40 times 15 plus 60 times negative 15 divide by 100 to give me the overall angle of rotation. You get what I'm trying to say? So if you're looking at here and you do the maths by observation, you will notice that this will surely come out with a negative number, right? Why? Because you got a higher percentage of the negative rotation or the anti-clockwise rotation optical isomer. Okay, so we can ask you something like that. And in this case, if this is more than zero, or rather it's a non-zero value, okay, then you will have to make the conclusion that this is optically active because it will rotate plane polarized light. Can okay, so it happens that I just thought of it, then I thought I should just remind you. Okay, this formula is quite commonly used. Right? If not, you can move on to part C, see whether you can solve for it. I will just do some gentle reminders of part C. You're okay, sir?
Also, as long as it's positive or negative, it doesn't matter.
Doesn't matter.
Because it's still angle of rotation.
Yeah, because if you calculate, this will be a non-zero. Whereas for the part where it's 50-50, right?
Yeah,
let's say it will cancel, right? You just observe, it will cancel. This will be zero. So this is optically inactive. Okay? Okay, we will most likely ask this more in MCQs. So just be aware. Right? Okay, I will just give you some gentle reminders for part C. Part C is very doable one. So what you are looking at is your organic chem. Okay, we are just telling you that ethene can react with bromine. But ethene cannot react with bromine since there is no mention of UV light. So they did tell you that the bromine was completely used up. That means it has completely reacted with ethene. Okay? Because only ethene can react with bromine at room temperature. So if you are looking at the 4 grams, right, you probably can calculate the moles of the bromine, which is actually equals to the moles of the ethene, because it will react in the 1:1 ratio. Please know this simple fact. So if you know the moles of ethene, then you should proceed on to find for me the volume of ethene. But are you able to use 24 dm cube? In this case, you can't, because this is not at RTP or STP, so you can't use the 22 or 24. So you have to actually use these two values over here, 27 degrees and 99.3 kilopascals. Apply your PVNRT. Okay, so before you do that, can I just write down a few things here to remind you? In ideal gas, you must convert meter cube or cm cube to, cm cube or dm cube to meter cube. Okay. Obviously, you all know how to convert Kelvin to degrees Celsius. And the last one, please know how to convert ATM to pascals. Okay, not kilopascals or pascals. Okay, so pascals and Newton meter minus 2 is SI units. But normally, you all won't use Newton meter minus 2. That one more for physics. Okay, can you all try that? Then after that, you can move on to question 4 already.
Conversion. Pascals. Pascal just 1000. What's the kilo? They just 1000. No need to convert anymore because it's in Pascal, but you just use 1000. ATM is 101325.
1 ATM is 101325.
Why? Not about. Okay, this one split. This balance, this balance. We cannot balance it one shot because this is for multiplication. So you need to create one equation for that. One equation. They are both not equal. Yeah, so just tell your first. So you go through the balancing.
And you get everything in the actual.
Okay, can review. The answer will be meter cube or routine value. Yeah, correct. Yeah, I should remind the rest also. I wanted to tell everyone.
Remember something, those of you who are calculating and you didn't get the answer, you probably need to remember that 1 meter cube is 1 million cm cube. This is just a mini fact, okay, in case you forget. 1 dm cube is 1000 cm cube. Okay, very important. But yeah, Darryl, your answer is correct. 6.2 is correct. You just move on.
dm cube to meter cube, you see here 1000, right? 1000 times. So you think for yourself, this and this.
Okay.
You always remember these two good enough already. Yeah, cannot variation. About 49 is the one. You will not get it. Yeah. 50.1 and 49 point something. Yes. So you round up, you will not be exact.
Move on. Because it's volume, then this is cm cube, so you get. So you get 2 times 6.
Yeah. Okay.
Why is cm cube?
To balance. Yeah. Combine both. You can. Yeah. So you can combine both. Then this is the. This is the 18. Divide by the 1.55. Yeah, that's the answer already. Because your 628 is the 18, you are on the right track. Then you divide by the total.
Which is 1255.
Yeah. The 1255 consists of both gases.
No.
Okay, let me talk about question 4. If you are done. Hey, those of you who are checking or working online, you have the answers on the PDF, so you can just turn back to look at it. Okay, I just talk about question 4 introduction first. They mentioned that you got chromium oxide. So chromium oxide is a solid. Even if you do not know that, they did tell you that this is a cassette tape and is 0.05 grams. So we can probably make the conclusion that it's a solid. You know why I need to know that? Because in redox, right, if this is a solid, you cannot change, you cannot act smart to change this into Cr4 plus. Although we know that Cr4 plus exists within CrO2. Okay? So what's this is an old question. So anyway, going back here, chromium oxide, this proportion needs to form Cr3 plus and Cr2O7. And what you probably can tell yourself is that in order for you to get this equation for this proportionation, you need to create two half equations. You need to manually solve for two half equations and combine them. So what are these two half equations? I will just write it out here to help you kickstart. Half equation 1, half equation 2. You need to start balancing in this way. CrO2. So this is probably something that you all have mastered in electrochem also. CrO2 and Cr3 plus, CrO2 and Cr2O7 2 minus. Okay, balance it manually. The sad news is that these two equations are not in data booklet as I was just telling Alicia. So you have to manually solve for it and combine it without careless mistakes. Okay. I will show you the steps if you need it. Give me a second. Okay, so this is just a reminder. Maybe I just flash this out. The 4 steps here. Okay, by right, you don't need this now. Okay, I will expect you to know this already. Okay, can you try? I will only check your final equation. If it's wrong, then I will just check back your half equations. Did I tell you all not to use the blue bottle, the blue acid bottle? I told you all last week. Did I tell you a story? Didn't tell you the story. No, man. I thought it happened quite some time back. Okay, so your good friend Sofina, your newfound good friend who was also my good friend but now become your good friend. So bad. So she came on Sunday. Then she was studying outside. Then the bottle that y'all got is the freebie, right? Where will you see plastic bottles breaking one? So she just drink and then accidentally drop it, right? The entire circumference of the bottle at the middle, right, just cracked into two. And it was just probably dropped from the table to the ground. Then
the water dropped.
The whole floor is wet. But because I was not around, then she ended up having to mop the place. But that's not the point. The point is that the bottle is damn chalat, right? Bad quality. Why would you see a plastic? You want to buy a $2 water bottle from Daiso, it was open crack, right? Yeah, so that goes to show how bad it is. You know, it brought me to, it reminded me of this story. Many years ago, Teachers' Day, they announced on the email, they want to give all the teachers a power bank. Remember I told you all this story? So they give a power bank, right? So we were very excited. Last time, 10 years ago, power bank not so in. So if you have a power bank, actually I had a power bank back then, but you receive a power bank, you will think, wow, quite worth it, right, for Teachers' Day. Then end up we receive the gift. Guess what it is? It's just a bank without the batteries. It's just a container, very light. We were thinking, how come the power bank so light? Then we open up, then we realize it's just a container. And we look at it, then we realize, right, that power bank requires us to put batteries inside to power the power bank. It's like, what? Yeah, so it's very ridiculous. It's like a cheapo thing that costs probably like few dollars only or even few cents only. Then we had to buy batteries. And obviously, nobody went to use that because we can just buy power banks directly. Right? Why would we want to use a power bank that requires us to put batteries? Quite dumb, right? Yeah. So I realized that the school is very bad at procuring items. Yeah, really, that was the lesson I just learned from.
You haven't seen my school.
Yeah.
Haven't seen
Is it? Oh, next time must tell me. Okay, let me solve this together with everyone. If you are stuck, so at least I can verify your answers before I show you the final equation. Okay, so just double check. CrO2, Cr3 plus. Okay, so you have two oxygens. You need to balance it using 2H2O, right? And then you need to balance it using H plus. So you have 4 hydrogens, you balance it using H plus, right? And last but not least, you balance electrons. So that is your first equation. Okay, so that one is not difficult. Then the second one, CrO2 to Cr2O7. Please be very careful. Some students make careless mistake here. You need to balance the chromium first. You never balance chromium, then the whole thing is wrong already, right? So I will times 2 here. 4 oxygens, 7 oxygen on the right. So outstanding of 3. So I'll add 3 H2O, right? Then after that, I noticed that I got 6 extra hydrogens. Then I will add 6H plus here. Okay. And last but not least, I check this charge is 0. This charge is 4 plus. So I need to add 4 electrons here. Okay. So I successfully gotten my 2 half equations. So what I need to do next is to combine them. No? So there is something very important to be remembered for combining equations. Always remember to ensure that electrons are equal and cancel out the H2O. Okay, so this is just a reminder to all of you, right? So going back to here, all you do is to ensure that you multiply by 4. This entire equation multiply by 4 times and you combine. Okay, I will show you the overall equation in a short while. Okay. Part 2, I got a shortcut method. Or not shortcut, it's just a slightly more convenient method. Instead of writing equations, and this will probably form the foundation for the next few questions also. Especially those of you who didn't attend mole concept redox with me, then I think I probably should introduce this method to you also. Okay. So you have your overall equation. Let me just open this up. Okay, can you just check your overall equation? I just need the first one. Okay, the second one I don't need it. Please don't write the second one. I will probably show you a cleaner method. You check your coefficients. This after I combine. So can you just check? Because in case you didn't get it right, then it's proof to us that you didn't combine correctly. Then later they will affect the next part. Your mole ratio will be wrong. Will you show any mistake? Okay. They're okay? Yeah. All right. I would talk about the second part first. So what they are doing here is they conduct a redox number 2. Actually, this is a redox back titration, right? Redox back titration. So you are dealing with dichromate. So this dichromate is your product. Can you see that? This is your product. So this dichromate is in your conical flask, by the way. So I always like to visualize in terms of the apparatus. So it helps you. This dichromate is in your conical flask. What you are trying to do is to actually use a burette that is containing Fe2 plus to react with the dichromate. Okay, so you are using the moles of Fe2 plus to solve for the moles of dichromate. The reason why I don't want you to write another half equation, right? Or rather, I don't want you to write another overall equation is because it's time consuming. So all I need to do, right, is to find out exactly what's the mole ratio between these two. I want to find out what's the mole ratio. If I know the mole ratio, I can solve for the moles of dichromate. So how exactly do I do that? I will just show you this working first, and this will probably form the foundation for the next few questions to come. OA, let me just write this down better. OA, electrons RA. Okay. So what I'm trying to show here is that this is in terms of the arrangement of the data booklet. The data booklet left hand side is always the OA. Electrons, RA is always on the right hand side. Who is your OA here? Your OA here is your Cr2072 minus. Your RA is your Fe2 plus. Okay, this is just a quick working. In fact, you don't have to show this if you don't need it. But what you probably can check from your notes, right, or your data booklet, sorry, is that the ratio between your Cr207 electrons, this is given. This is 1:6. All you do is to check your data booklet. It tells you that. Whereas for iron, what will iron be oxidized to? During this reaction, iron will be oxidized to Fe3 plus. So we know the equation for iron is Fe2 plus, Fe3 plus plus electrons. So this ratio between iron and electrons is 1:1. Are we okay so far? So this is just a quick way to solve this very fast one. You don't need to write another half equation. So after I tabulate 1:6 and 1:1, right? Then I should tell myself that the overall ratio for this relationship is 1:6. Are we all comfortable? 1:6. Okay, where do I get these two ratios from? These two ratios are from the data booklet. Data booklet, data booklet. Okay. Yeah. So if you are not very sure about this, I will repeat this a few more times until you can apply to the other questions also. So what's the moral of the story? I can get the mole ratio between Fe2 plus and Cr207, which in this case is 1:6. Okay, so all you do is to find for me the moles of Fe2 plus. You will then be able to find the moles of Cr207. Okay, I'll write it out here. Okay, give me a second. Okay, so if you look at the question, you can already solve for the moles of Fe2 plus. This was given in the question. Okay, all of you can count that. Then I can solve for the moles of Cr2O72 minus, which is divided by 6. Okay, can I calculate the moles of CrO2? Can. Using the first equation that was asked for, this is multiplied by 6 again. Okay, so these three values you can solve. After that, you can solve for the mass of CrO2. Okay. Yeah, correct. Merge the two ratios. Good. We'll practice this a few more times. Don't worry. No, actually, that last year you got do before me, but you forgot already. That is method, right? Okay. Because we really don't use this in school.
Got primary school ratio one. The ratio of the three things, right? Then got one to this one, then the bottom got another two ratio.
Yeah.
Then it's like,
Oh,
remember,
yes. We learned this in long time ago.
I remember that it's like super.
Ratio is primary school, right?
Super clear.
Not secondary school, right?
No. Secondary school don't have. Last time is orange to red to green. Then got three different ratios.
Oh, yeah. The balls.
The balls.
Yeah, you put the balls. Orange balls, red balls.
Or like beads.
Yeah. Hey, now if you do primary school question, it's not this kind of. Yeah, I don't think we have
we actually went to
all these simple.
Then we always go to the popular, right? Then we open all the primary school books. Then we go and see, right? Actually, not easy. Right?
Yeah, not easy. I can tell you, very hard.
You never take. Yes, sir.
Oh.
So
Prodigy. Skip PSLE. I know your story. I know your story. It's okay. I'm just joking. Okay. I just quickly flash this out so at least you can see this. Okay. So you know this ratio, you can solve for the moles of chromium dioxide lah. Okay, then you can move on. Right. Okay, can I don't, if you start on question 5 already, you can continue later. Maybe since you're on Redox, right, I do a jump. Maybe I can get you to try question 6 and then I let you try 2 MCQs to just boost that concept of the OA, E, and RA. Okay, so later we can come back to question 5, don't worry. Right? Okay, let's look at question 6. If you are done, read through that first. I will elaborate on it in a short while. No. Oxidizing agent is the Cl2. Yeah, it's the one that organic chem. Fe2 plus. Yes. Okay, try question 6 first, then I will talk about it in a short while. This is 1:6.
You see this the ratio of Cl2 to Cl1, which is the same as the ratio of iron to
Okay,
iron to this.
I will elaborate on question 6 first. Okay, so at least you can go through that with me. Okay, I'll just do some color coding. Fe3 plus, you have this concentration, 25 cm cube. So what's happening is that Fe3 plus is being reduced to Mx plus. Okay, we don't know what is reduced to lah, but we know that zinc is acting as the Ra. I'm just writing it out so that it's clearer, because some of you are not very sure about what's happening. So Mx plus was being oxidized back again. So if you look at the question, right, they are saying that the resulting solution is the Mx plus. Okay, it was being oxidized back again by MnO4 minus. So I remember one year a student asked me, why so bo liao one? Reduce and then oxidize, like what's the purpose? I mean, there's no purpose lah. It's just a question, right? So what are we trying to do here is that we actually know the moles of the MnO4. If I box this up, we know the volume, we know the concentration. So if you know the moles of both species, which are actually your MnO4 and your Mx plus, you can use that method I taught you. Okay, I'm gonna just slowly write this out again. I'm not interested in path equation, really. Unless the question asks you to give me an overall equation, then I'll be interested to write it out. You know, it's a waste of time. Okay, so OA, follow through slowly with me. You're not sure, please ask me. OA, E, and RA. And I have a reason why I like to write this way. Because OA is always on the left-hand side of data booklet. RA is always on the right-hand side of the data booklet. Okay? So I will just write this out. RA will always lose electrons. OA will always gain electrons. This is just a reminder to you lah. So what am I writing down as my MnO4? MnO4 is my OA. As always, it will never change, right? Electrons. Okay, and the one in red is your Mx plus. It's not the M3 plus, it's the Mx plus, which is what some students are confused about. Yeah, the Ra is zinc, but you realize that I do not know the amount of zinc. The question never give me the amount of zinc, so I cannot use this ratio to solve. Okay, if I know the amount of zinc, then yes, we can proceed for redox 1. Zinc and M3 plus we can find out. But here they never say that the zinc is unknown. So I will skip zinc. That's why this question there is something additional, right? I should be looking at the unknown MX plus and the MO4. So all I need you to do for me, very simple. Can you calculate for me the ratio of these two things first? These two things, yes, in the data, in the question. So use the box up values, multiply the most, get the most out, and find for me the simplest ratio. Can you all do that? Okay, some of you are probably familiar with this method if you have been through this with me for more concept. But even so, that was quite some time back already. Okay, so I think we better revise this. Okay, so if I'm not mistaken, your mole ratio should be 5:1. Yes. Okay. So this is from the question. This ratio is from the question. I'm just writing out so that it's more explicit. Then do I know the ratio between the electrons and one of the agents? Actually, I can do so. I don't know the ratio between E and MX plus, but I do know the ratio between MO4 and E, which is from your data booklet.
Which is 5.
Yes, which is 5:1. Correct. So it will be here. Correct. I just write it separately so that it's more apparent, or rather it's not so confusing. Okay, so this is from data booklet. Then I will combine all. I mean, of course, I can do it faster by combining them from the start. So 155. This is the section that, again, another group of students will make mistake. You must then remember, MX plus is trying to be oxidized back to M3 plus. So if you were to look at the ratio here, if you articulate that out, then you must tell ourselves that 5 moles of MX plus is losing 5 moles of electrons. Okay, even if you don't write this out, at least you articulate that in your head, right? So you ask yourself, this is your RA, lose electrons, 5 moles lose 5. That tells me that 1 mole of MX plus loses 1 more electron. Even so, this part also got people make mistake because they will write the wrong equation. So I'm going to write down here, MX plus its eventuality is that you become M3 plus, right? Lose electrons means you must write on the right hand side there. So it's here. It's not on the left hand side. If you write on the left hand side, you will get the wrong answer. Okay, so if you solve for this, then what you are getting here is actually, what you're getting here is actually x equals to 2. Okay. So I just quickly write the ratio again because it disappeared. Okay, with that in mind, I will just quickly get you to solve 2 MCQs with me. Then we can take a short breather, or rather you can take a short breather and then solve the MCQs also. I will just flash it on the screen. Okay, so you can just try it. Right? Yeah.
How do you know the first ratio, 1:5?
Or 1:5 is from these moves. But there was something that I didn't mention. It's actually all along the moles of M3 plus is equals to the moles of MX plus. Because it's conserved. Right? So yes, even though it reduces and oxidizes, but the moles of M3 plus is the same as the moles of MX plus. That's something I didn't mention. Okay. So this is from the question. This is from the data booklet. Okay. Can Daryl, okay not? Okay. We try 2 more. Okay. Daryl, okay. You keep asking on Daryl, never ask for Daryl. Okay. So I show you 2 MCQs. If you want, you can take a short breather and then come back to try it. Let me just open it up. Here. Some of you have this already. you may have received from me in year one. I cannot remember whether I did give everyone. But oh yeah, you all have this. Turn to the back. Actually, I don't need to flash out. Just turn to the back of that set. You have that. You have this. What am I saying? Why I keep thinking you're JC one or doing this. Got the wrong timing.
Time too short.
Yeah. Okay, so I'm going to try question 2 and 3. My objective of showing you the method, right, is to ask you to solve fast using two. You have this set. It's in the. It's, huh? Oh, you did before. Okay. How can I do before?
You send the group there.
Huh?
You send it in the group.
Oh yeah, you send
That's all.
Oh, you did first lah.
Yeah.
Oh, then okay. Then no need to. Then you can try the other question. No? Yeah, I sent in the group. But here you all have it, the printed version, so you can try. Objective is to solve it in 2 minutes. Fast one. You can try other MCQs or you can take a short breather. Your answer is D and B.
Yeah, you got sent before.
Okay. Yeah, then choose first. You can choose first.
Okay, let's see the name. You say all these things, later you say hi, then you don't even know.
Okay, I'll just work out together with you so that if you are done, you can check. What about saying hi?
No lah.
Saying hi. Say hi.
My mother like shy. Always before when you're not talking to my mother, like talk about her. Wow, very big one.
Yeah, normal. Isn't it normal?
Like his friend like that.
Yeah lah, that's normal.
Then meet the real thing and put together. So my brother compare. My brother just got his license. Then he tell me what he want to say hi to him all. And later say hi already, I'm scared already. He won't say. Funny man.
There are quite a number of these kind of questions in this set. If you haven't finished it the other time, you can also do later on in your free time. Okay, I will just get you to try 2 with me. What thing? Oh, Gabriel is there. Yeah, do you want to convey any message to him?
Say hi.
Oh, Gabriel, Josh misses you and say hi. Say hi is very unfeeling. So you must add on.
Oh, you should say I'm thinking about him.
I just write out the whole working on the screen so that everyone can check. In case you are trying to accustom yourself to the method. Okay. So I think my objective is very simple. I just want you to solve fast. That's all. Some of you can take like 5 minutes for 5 or 10 minutes for this kind of question. Okay. Okay, you can check. That's for question 2. Even I write out also, I need to write using 2 minutes. There, you can also do, maybe if you are done with those 2, you can also try like maybe question 6 or similar one. But if you're confident already, then no need. Just do others. Oh, it's okay. Yeah.
The reason why it uses 2 is because it's 6 into 3, right? So it's
Yeah, correct. Yes.
okay.
I already jumped the step. Okay, so it's actually derived from the 3/6. It takes some time to digest this. If you are faster, then go and scare yourself to do question 7 or 5 and 7. Even when I see my ex-teachers, I also be quite shy now. Not to mention that you see other people's parents, right?
All the parents top one, no, all the different, this kind of thing.
Even I see my ex-teachers who become my colleagues, I also will be shy, or I pretend to be shy. No, I was not from SA. Yeah, but the fact is that, I mean, when I see teachers who have taught me before, whichever school primary, secondary, or yeah, I also feel shy. When I go back to my primary school and visit many years back, I also feel shy. Okay, if you are okay already, then you may want to just try question 3. Then if you cannot solve it, then I'll come to you and check. Then after that, you can OT start on 5 and 7. I'll probably discuss question 7 a little bit more. Okay. Then number 2, zinc is oxidized. Then you can treat it as V5 plus. Later on, right now it's okay. But if you're looking at VO3 minus, eventually to solve the question, just like the terrenium, you will treat it as V5 plus. Yeah.
Is VO3 minus become VN plus?
Yeah. But you don't have to find I mean, you in the beginning in the table, you're writing V5 plus.
You're reducing V.
Yeah. But zinc metals will always be oxidized. Remember that.
Yeah.
All metals are Ra. Very important concept for natural chem. All metals are Ras. Not ions. Metals are always Ra. Okay, I'll just write out the next one. Okay. Okay, so double check your ratio. Okay, once done, I think you just move on to question 5 and 7. 7, I will discuss it. 7 is really very hard. 5 is pretty easy, so you can try it first. 7 will be the tougher one. Okay. So I will just write down 1 mole. Alicia, I didn't go through this with you before, right?
I think you did.
I did, right?
Yeah.
Yeah. I mean, when you first last year, did I go through this one?
I think that period of time, like before Chem bonding.
Oh, okay.
Mr. Lai, he was asking also whether I got do it.
You do the workshop ma, different.
Oh my god. Oh yeah.
You did. Actually, I remember especially that what you did.
Oh yeah. I remember.
Wow. Something I probably won't remember. This kind of thing I remember.
I think it came right before organic started. Yeah.
Okay, with that, I think if you want to do more of this kind, there are quite a number sprinkled across the MCQs. So just feel free to try later on. If you are okay, I think I would rather you probably focus on question 7 a little bit more. You can just try that. Then I would talk about the question first. Okay, so you just read first, then I would tell you what's happening so that it's clearer, because this question is a bit hard. It just so happens that this set, all the Victoria question are hard. Question 2 and question 7 are all both from VJ. Yeah, both are the prelim papers from VJ. Okay, let me close this. Darren and Josh, this one okay. I close this.
I don't know, sir.
You check.
I don't know why it becomes 6.
Why become 6? Where's the 6?
The 6 electrons.
6 electrons. Oh, because this one comes 3 ma, LCM. Lowest common multiple. LCM.
No, because my ratio answer is
2 plus.
my ratio is 2:1. 1:2.
Okay.
That's why I got.
Okay. Let's look at 7. Read first. Scare yourself a little bit first before I talk about it. Right. Yeah.
Last time I always cannot do Redox.
But Redox must keep practicing it. Really.
Is that there?
Yeah. Correct. It's like maths. It's just that A-level Redox can be very hard. And A-level more concept can be very hard. Okay. Let me just break down this question because there are 3 Redox happening here. Okay, listen. Okay. So I will just use color coding here so that you read the passage together with me. Number 1, they say the 0.53 grams of iodide is actually broken down into iodate, or not broken down, converted to iodate. Okay, so this is the redox that's happening. Iodide is being converted to iodate. Problem is that we don't really know this iodate. Is it IO3 minus or IO4? All right. And we also know that, or rather the question did tell us that XeF2 is converted into Xe, or rather it's reduced. Okay, it's being reduced. Because the idea here is that Xe2 plus is being reduced to Xe0. That was what the question told us lah. So if you follow my red color one, I'll just try to be as neat as possible here. XeF2, I'm not going to write balance equation yet. XeF2 react with I minus to give you Xe. This is just to draft it out. And I will then in turn achieve iodate. So you can just jot this down if you want to. IO4 minus. Okay, let me just push this up a little bit. Oh. So that's the idea, first one. Okay, let me move on to the second reaction. Anyway, it's all redox. So I will just call this R1, R2, R3. Redox 1, redox 2, redox 3. So it's very mind-boggling. Then they mentioned, subsequently, the resultant solution was acidified. The resultant solution is actually the iodate. Of course, I know there is the xenon, but apparently xenon is a noble gas or noble substance, right? We don't expect much reaction. Okay, that's number one, and didn't mention anything else. So the resultant solution was acidified. Let me just color code this. Number two, and added to iodide. Okay, so I'm gonna just write down here IO3 minus / IO4 minus. We don't know which one is it, by the way. And then I want to react with I minus again to give us I2. Okay, you look at my color coding, I form iodine. Okay, can anyone tell me what's the name of this reaction? Number two, think of the name. I know quite rusty already. Two things, give me one oxygen. Huh? Close. Close to what he said. Opposite. What? No, this is split, this integrate, divorce, whatever. Combine means comproportionation. There's this word. But yeah. But although not all schools teach this officially, right? But we can still test you this because it's still redox. Okay, so you don't need to know the name, but it can still pop up for questions, because they can ask you, this is still a redox equation. This proportional and comproportional are those examples of redox. Okay, anyway, this is not balanced, and I don't need to balance yet. So the blue color one is these two sentences. Okay, I hope you are still following me. So this part, so the last one I write in purple. Where is my purple pen? Yeah. Okay, so number 3, then they say, this can be in your prac also, So they ask you to use thiosulfate. So what's happening now is that I2, this is something that all of you are very familiar with. I2 react with thiosulfate. In fact, I'm just writing out the equation because it's very easy to balance. Okay, if you don't know how to balance this, then I will be worried for you. Okay, so anyway, so these two I minus and S4O6. Okay, both can be balanced using the data booklet quite easily. Okay, so the purple one is balanced already. Okay, so do you know the moles of thiosulfate? You know is given. This is the moles of thiosulfate, right? So if you know the moles of thiosulfate, are you able to find the moles of iodine? Definitely, because the mole ratio is already established in equation 3. It's just divide by 2 lah. So I don't think you will have much trouble with that. Okay. So what's the objective of this question? If you read part A or part 1, they say deduce the identity. Okay, deduce the identity. So I know this iodine moles here. Okay, that's why I'm circling here. I know the moles. I can find that out. But do we know the moles of iodate? Actually, we know. You know how I find out? It's because the iodate came from the 0.53. All the iodide here, I repeat, step number 1, all the iodide here was converted to iodate. Do you read this sentence? All the iodine is converted to the iodate. I repeat, all the iodine is converted to the iodate. So are you able to find the moles of iodate? Technically, you can. Okay, I'm going to just circle this and circle this. You know the moles. I'll put a tick here. You can find the most because you can find the most of Ki and you can use that to find the most of this one. Do you know the most of I2? You definitely know that. Okay. So if you are doing this question, right, number 2, can I ask you to apply what you've done in question 4? Question 4, just now you all did, right, the disproportionation one. You created 2 half equations to combine. Do you need to create 2 half equations here? You need to. You need to create 1 half equation for iodide to I2 and need to have another equation for I minus to I2. Why? Because you already know the mole ratio between these two already. This just 2 steps only. After that, you solve for the half equation. Okay, the half equation, after you combine, you can check, do they fulfill these 2 mole ratio or this particular mole ratio that we have just found out? Can you all try that? Find for me the moles of I2 first. Step 1, find for me the moles of iodide from iodide. Step 3, go and write the half equations for number 2, redox number 2. It will be a painstaking process, but if you're not careless, you will get it one. Yeah, 3 marks only, guys. It's tedious, ma. Okay, so this can be your theory paper or your back titration. It's your back titration anyway.
So you have to, you must IO3 to I2, then IO4 to I2.
Yes, yes. And then combine both, combine with the I minus. Yes, yes, yes. Can get one. It's very methodological.
But the mole ratio must be 1 to 2.
No. This mole ratio we haven't found yet. You go and find.
I mean I2 to I minus must be 1 to 2.
No, it may not be. We are just interested in finding this mole ratio after you balance the equation. Okay, you check what's the mole ratio. I can tell you the mole ratio is 1:4, but of course you have to prove that to me. Okay, I repeat, you have to find for me 1 half equation for IO3 to I2 and IO4 to I2 after you have found the moles, of course. Okay, so I write down the steps here. Number 1, find the mole ratio of iodide to I2. Number 2, half equations of IO3 minus to I2 and IO4 minus to I2. Okay. Then after that, get the overall equation of redox equation number 2. Okay, no, there, this one, you find for me I2 and IO3, IO4. You know the 0.53, use that to find the most. 2 steps only. Darren, is it that you did the primary school is the UK side? No, Canada.
I was in Taiwan.
Oh, okay. I thought it's some more country.
Almost school.
Oh, but Taiwan quite fun, right? Yeah, very happening. Well, your age is not happening. Now, yeah. Oh yeah, talking about Taiwan, I got a story to tell you, but later. I'll just check for some of you first. Give me a second. Because I realized I was checking some of your workings. I will write down here before you move on. I write down the steps on the board already, so you don't panic. Your ratio will be 1:4 before you carry on. Okay, so you can check. But this two is from the question. This mole ratio is from the question. So find the moles and
of course. That's the tough part. Actually, the rest not so bad. It's just the. So, but right, how come your Chinese is not as. Okay, okay. So that's why it's not good. Also, just yeah, you found the most already, right?
Yeah, but then I do this one.
I2 you know from thiosulfate. Okay? You know the thiosulfate. You can find the.
And more ratio.
then here. If you know the thiosulfate, the purple one, you can find the I2.
Oh,
You just need to find for me the most.
I do.
Can. Now I'll check. I'll just double check your working. Where will you get bullied there? Will you victimize it?
No, she's the bully.
It's a bully. Again,
He bully me now also.
Balance first. So later you will combine with, after you get each of these, right, you will combine with the standard equations for I minus to I2. You are on the right track here. But you need to combine this one. So this one, you combine this one. The I04 one also combine this one. And then check the ratio. Okay. This way, so you do I2, okay. Then you found the iodine already.
The iodine is the same as the iodine. The I2, I minus. Because it's all of it.
Yeah, correct.
Now, how do you know the ratio?
Huh? The ratio? No, you are only required to find the ratio between
I2 and
iodate and I2. You find for me the ratio. Iodate and I2. You found I2 already?
Yeah.
Then you found this one already, right? I flash out the first part. Then you will feel more won't die lah. It's just that you will be very tedious.
Wait, how do you know that the moles in iodine?
Because 0.53.
No. Isn't that a highlight?
Yeah, but then you say
You show him the center. Yeah, so I just flash this out first so that at least you can check along the way. Okay, all of you have the answers. There is no need to blindly copy, okay, because it's on the PDF. But then please try to work out the half equations. I'm just showing you this to have your milestone check. Okay, I don't need this equation, this one. This is probably one of the harder ones really lah. Okay, but again, just to share with you, redox can be quite difficult.
So it's the mole ratio of iodine to I minus is dependent on the reaction, like the XCF2 thing.
Yeah. But I'm not interested in finding the mole ratio for redox 1.
right?
Oh, yeah.
I'm not really that interested. Redox one is X,
Oh, okay.
right? Plus, so I'm not really that interested in doing this because it doesn't help me solve the question. This is not balanced. This is not balanced. I'll probably need the second equation.
Alright. You sure okay?
Yes.
Yeah, after that you can just you can skip part two. Part two I don't need it. There is something in this context that you are not aware about. So let's skip that first. You can do question 8. Yeah. Yeah. Oh, because even if it's even if what you told us is not clear, we can probably see from here because there is no other iodine containing product. Example, I give you a simple case. Let's say I say that methane combusts in oxygen to give you CO2 and H2O. Then I probably have this idea that all the carbon was harvested from the CH polymer because there is no other carbon containing product. So this is just the context here. Even if they didn't say, actually we can deduce this ourselves by right, but you need to use the question information. So be careful, you eat all the glass. Really, no joke. Because you always use phone when eating, then the glass shreds will always drop out. Yeah. It's just very small. Tempered glass means that it's not sharp edge. It doesn't mean that it's not. Yeah. It's not sharp edges only. That's the idea of tempered glass. Yeah. No, it's a mixture. Tempered glass contains sand, so sand contains SiO2. That's the only thing I know. But glass has a lot of different types. You got those and tempered glass inside got the wires. Yeah, got those hidden wires. Yes. No project.
We make battery, you
Make battery. What do you think tempered glass? Okay. Okay, I just flash out the top again for some of you who are still not very sure. You can look at the steps. Yeah, correct. You got it here. What's the one? Then after that, you solve for this equation. You need to solve your half equation. Right down here. It's here. You need to solve for me. Yeah, at number 2 now. You solve for me this and this, then combine with the equation for I2. I minus to I2. You do it manually. Right. This one combine, this one take this one combine this one. Okay, check whether it fulfills 1 to 4.
It's I04.
Yeah.
Can I use the letter just now?
Huh?
Can I use the letter just now?
No, cannot. Which method?
Oh, yeah.
Cannot, because this question, although it's about unknown oxidation state, but I probably will not know the electrons involved also, because I don't really know which species in the first place. No? Okay. I'll just flash back to this one first. Okay, those of you who are done, just go on to try question 8 and 9. Again, these two are okay. 8, 9 are just your typical titration context. Okay, just to make sure that you are able to do dilution and extraction. Okay, that's all. Actually, the thing is more concept you must practice. It's not so much about reading the paper 4 practical notes. You should just practice more. And then, of course, mark your planning question.
Okay, that's small. Yeah.
Sorry, IO3. Okay, I double check. Let's check it again. Maybe I zoom in. Okay, it's clearer. Yeah. Yeah. Okay, there is. Okay. What is all the things that you want to take note of?
What do you know? Power gen.
Oh, no. Okay, I just move on a little bit. If you need this back later, I will just come back to the ratio. For question 8, I just want to give a gentle reminder about the context of dilution and extraction. Most of you would know this by now, okay? But always look out for the context, because if you are doing practical or titration, we will definitely like to test your calculations on this, okay? So in this case here, you have dilution, right? This is diluted to 100 cm cube, and you only extract a 10 cm cube. So in short, what we are looking at is that originally you have a small amount here, or small volume. You add water, and you become 100 cm cube. Okay. So the context about dilution, just to remind you, dilution always results in lower concentration. Okay, this is something that all of you are aware about. Okay, so dilution concentration will drop. Okay, but your moles will remain the same. Okay, so this is just a gentle reminder. Then extraction means that you take out a certain percentage of your moles, but concentration will be the same. Okay, so in the second part, they take out a 10 cm cube. Usually you'll be using a pipette, right? So you take out a 10 cm cube, and this 10 cm cube is actually titrated against a certain substance in the burette. Okay, so you would have expected the burette to be here, and this is your S2O3 2 minus. Okay, so you should work towards that. So redox back titration, go and solve for the using S2O3, solve backwards to find the amount of the OA that you're looking at. Okay. You got it or not? The ratio. This part. You can check your answer later. Okay. So this one you can try first. The question 8 not urgent. Question 8 you can actually go back and try. No issue.
We have to find the original non-diluted.
Yeah. No, you need to find work backwards on. You find your tires sulfate. Yeah. Then you can find the most of the other substance in the connector plus. Right. So you can find PB2 plus. That's what you're trying to do. Yeah, you're saying sorry?
No.
Oh, you're checking. Okay.
Okay, so if you get one of previous, if you get one of them,
Of course. Actually, the problem is that you must solve for the correct one. You cannot solve using the wrong ratio. Let's say this one you get wrong. Maybe you don't. Huh? Yeah, I mean if you manage to get this right at the first time, then maybe you can afford to do this. You get me?
I don't realize
I do this speaking in my solve
that's
wrong.
like saying distinguishing test you get one.
Correct. But my way of telling you is that if you manage to get this first, lucky, we can still close one eye and accept it, even if you prove this. But if you prove the wrong one, and then you tell me because this is wrong and the other one is correct, then I cannot accept because I don't see the correct answer. I didn't see a correct ratio. Okay, question 8, last question for the day. Most importantly, you again must realize that your I2 is reacting your thiosulfate. Okay, so it's very standard equation. I2 is going to react with your S2O3 2 just like just now. Okay, to give you 2I minus and S4O6 2 minus, correct? So the idea is that if you know your thiosulfate, you can solve for the I2, right? You can divide by 2 to solve for the I2. Then of course you should find out for me how to find the original amount through the dilution extraction. Because this I2 you know. If you know the I2, you know the mole ratio of PbO2. Easy one, this one. 1:1. Okay. The 2.5 gram sample, this is probably impure, right? This has a mixture. Okay, so I'll just flash this out. You can double check your answers. It's a very short calculation. So I just write down some key ratios. Divide by 2. Divide by 2. Yes, okay. more is better. Okay. Yeah. Is IO for okay, anyway, if you solve for 8 already, that's fine. Okay, so what you probably need to go back and try is just practice more. Okay, you can just try question 9, 10, or just do more MCQs over this period. Okay. But I think the priority really is focus on your paper 3. Okay, I know you have a lot of things. I will give you stuff, your school will give you stuff. But someone asked me whether you do a TYS. Actually, TYS by right we should do after prelims because everybody does the TYS, but mostly A levels seldom repeat TYS question one. Really, I can tell you that. Okay, it's not like O levels. We always keep repeating the O level MCQ. At least seldom. So actually now, even though school asks you to submit TYS because school will not see you so much after prelims, so they are worried, and they will ask you to do 1 or 2 years. Okay, the more crazy one ask you to do one every year, which I don't find that useful lah. Because if you do TYS and that's a sure way to do well, then I think no need to do really one. Everybody just buy one booklet of TYS and everybody will score A and B. That's not the point, right? Okay, it's not like O levels. O levels I can assure you that you do TYS, right? It does help you secure your B and above. But A level a bit different. Okay, you can have finished all the 10 years of TYS, right? You can still do so paper 3, okay, really, and this is to prepare for both prelims and A levels. Okay, even after prelims, we still should do more prelims paper 3. Okay, so go and try that. Then those questions that you don't understand the work solution, then just feel free to check in with me lah. Alright. Okay, if not, I will end off here. Right. Anything just text me. Alright. Okay.